Okay, so we're going to be using logic. In the first bit, we'll use some different examples to show how we write logic in a program, and a few different examples of what we can do with it. The basic idea behind logic is making simple decisions in our code. And some of you guys already started to kind of ask questions related to this when we were working on our interactive design project last week. There's a few people who had questions about how would I, stop at a certain point as I'm changing colors, or how would I reset something, things like that. And, I probably responded, that's the type of thing that we would use logic for, which is what we're going to learn this week. So there's a lot of different ways to approach different problems in programming, and logic is one of the things that we can use to kind of make decisions or make choices based on what we want to see on screen, or how we want to change the way that a program works as the program develops. I'm sure you guys, have played video games where there's different levels. And so that's a good example of one of the things that we can use logic to decide. So we keep track of what level we're on. Right? And then we can use logic to say if we're on level 1, then we're going to draw the components that go in level 1. If we're on level 2, we'll draw the components for level 2, etc. And so pretty much every computer program has versions of those types of decisions that need to be stored as we're developing or as we're progressing through the program, and then choices about how we, what to draw. So let's give a couple examples of this, and we're going to start just with some really, really simple examples of logic. So we'll just start with a basic logic statement. Logic looks a little bit like a function or some of our other programming structures that we'll learn throughout the semester. So when we write a function, we use the function keyword. Then we have a name for the function. I'll just say function name. And then we have some parentheses, and then we have some curly brackets. So just like we have the function draw here. Writing a logic statement is almost exactly the same, but the keyword and the keyword is if instead of function. And then we don't need a name for our logic block. We just evaluate a condition. So we put a condition inside of our parentheses. A condition is something that can be true or false. So a good way to think about different conditions are when you're making binary decisions. When we make binary decisions, there are two choices, and so we're choosing between, yes or no. So, for example, you might decide you might be trying to make a decision about what to wear when you get ready for, to go outside and go to school or do whatever you're doing. And you might say, if it's cold outside, then I'll wear a jacket. So that's a good example of a binary condition. The condition of it being cold is used to determine whether we want to wear a jacket or not. And in computer programming, all decisions have to be kind of reduced down to binary decisions, because the computer kind of thinks of things in a binary sense. So you might have more complex decisions, like you might wear a jacket, you might wear different types of socks, you might wear a hat, but we can reduce all of those decisions down to either a yes or no, and by doing that, we can decide, how we want to proceed. So in a basic logic statement, we have the keyword if. They'll get a little bit more complex, but we're just going to start with a basic example. Then we have a condition inside our parentheses. And then in the curly brackets, we have our code block. This is what we want to run if the condition is true. So it's similar to a function where we have the curly brackets to write the code inside of, but it only runs when the condition is true, versus a function that runs whenever we call the function. So I'm going to comment this out, and we'll give another example. When we're evaluating a condition, we can evaluate lots of different things, but they have to evaluate to a true or false value. So this is called Boolean. A Boolean value is true or false. So Boolean is just named after a mathematician named George Boole, who came up with this type of math, essentially. It's not really important, but that's where the name comes from. And so a Boolean value is like a number or a string, but it can only be true or false. So it only uses one bit of information. It's either a 0 or a 1, a true or a false. And so our conditions might be more complex than true or false, but we can use syntax in basic math or other comparisons to reduce our condition down to a true or a false. So let's make a couple examples just using true or false values. So if I say if, and then I just say true here, then this statement is whatever code I put inside these curly brackets will be executed. It will happen. So let's say if true, I'll draw a rectangle at 0, 0, and width, height. And let's fill this rectangle blue, just as an example. So you can say we have, if true, any code that we write in here is going to happen. So we can see that we do, in fact, get this blue rectangle. And it's a little bright. Let's make it light blue. So that's, basically a basic example of a Boolean value. We can say if false, then let's fill pink, and let's draw another rectangle. And so you can see what happens inside the false section isn't drawn. We don't see that in our program. So whatever value resolves inside of our condition is going to determine whether the following block of code is run or not. So there's no real reason you would write a statement like this. Obviously, if something is just true and it's hard-coded in this way, there's no reason to have that there because it's always going to act the same. The reason you would want to have if true or false is if something changes. If some condition changes and we want to represent that change through a change in state. So let's do another example, but this time we're going to create a variable that can save the state of, it can save a value as a state. So I'm going to go to the top of my logic example program, and let's create a variable. We can name it whatever we want. So I'm going to call this variable draw pink background. So we want to name our variables based on what we are, expecting them to do. So if draw pink background is true, then we want to draw a pink background. So I'm going to set this equal to false, and then I'm going to set up a condition where this becomes true. So I'll make a mouse press function. We've seen these in the past. This is just a function that reacts to an event when we click the mouse. And what we can say is when we press the mouse, we want to change draw pink background. And instead of false, we're going to change it to true. So the value of this variable is going to change from false to true. So now I'll do the same thing again, except this time instead of false, I'm going to put in draw pink background. And then I'll just copy the same code here. So if draw pink background, so now I have a variable that can change between true and false. So I have a state in my program that can be updated by an event. So if I run my code now and I click, now the program changes. We get a pink, I'm calling it a background, but it's really just a rectangle. So we get a pink background instead of a blue background. All right, so that's a very simple example. We're going to look at a couple more complex examples. Any questions before we continue? Boolean, yeah. Sorry, can you say that a little bit louder? Well, so you wouldn't normally write something like this. This is just kind of an example. The false is not, this part is not running. It's the second part. So even though they look the same, let's change this to a different color. So I'll make this orange. So now you can see there's no orange background. We get the pink background because we're changing that value. So this is just an example. This doesn't make sense as code, because if you know something is false, you wouldn't bother writing this statement. This is just an example. This is just to show what these values are turning into. So even though we might have a variable or some other type of condition, ultimately they either have to be true or false for our condition to understand the code. All right, let's do a slightly more complex example. So this time, I'm going to use some basic math. And so what I'm going to say is if the mouse value is greater than a certain value, then I'm going to draw something. So when we're doing conditional statements, we have a few different ways of evaluating a condition, and they kind of go along with basic arithmetic. So I could say if, and I'll use mouse x here. So I'll say if mouse x is greater than 200, then I'm just going to draw an ellipse. I'll have to change the fill so we can see it. So let's change the fill to green. And I'll draw an ellipse. And it doesn't really matter where we draw this. Let's just draw it in the middle of our canvas. And I'll make it 200 pixels wide. So this is a condition where we're testing to see if one value is greater than another. So if mouse x, if that number is greater than 200, then we're going to see our green circle. Okay, so right now we don't see a green circle. And if I move across this invisible barrier, which is 200, now we see the green circle. So let's write x on the screen so we can see that. So I'll do text size is 40 and text is mouse x at let's do 20 and 40. That should be visible. And I'll have to change the fill so we can see it. Okay. So you can see mouse x is just a number, and its position is represented by a number. If it's all the way on the left, it's 0. And as we move it farther across the screen, the number increases to represent that position. And then when we get to 200, now this condition, if mouse x is greater than 200, becomes true. So as long as this mouse is over here, we'll see that green circle. Yeah. Yes. I'll do an example of that. Usually I cover that a little bit later, but we can do an example of that today. Yeah.
What's making it like in a code? Like how is it? Shouldn't it once it passes 200 be staying? Like how is it when it disappears? Like should it isn't it like printing the ellipse after you press 200? And once you go back, it's like going what?
Yeah, so remember that our draw function is running 60 frames per second. So it's repainting everything that we tell. All this code is running over and over again constantly. So even though we see the circle when the mouse is over here, as soon as my mouse goes back to the left side, this condition is now false. So it redraws like the pink background or the blue background, but it doesn't draw the circle. So we see it momentarily, but then it gets covered up. If we weren't drawing these other rectangles, like if I took these out and took out the background, then we would see it. but we would also see, the text is just a mush, and it's just, we see the whole history. So yeah, we'll look at a keybind example in a moment, but let's look at a couple other examples. So we have greater than. Obviously, we have less than. So if we can say if mouse x is less than 200, so this will be the other condition, then let's fill green again, but this time let's draw a rectangle. And I'll draw it at, I'll do the same values because it doesn't really, it's just an example. So now you can see, as long as x is less than 200, we see that rectangle. If it goes above 200, then we see the circle. So we're drawing just based on whatever those conditions are. We also have greater than equal to. This just includes 200 and less than equal to. So, that's another possibility. Let's look at, we can do it. Let's look at, since James asked, we can look at a keybind. So I could say if, and then here we're actually going to have a function inside of our if statement. So this is a little more complex. This is something I usually cover later in the semester, but we can see how that works. So let's actually look at our reference for this, because this will be helpful. So if we look at our reference and we go to events, we'll see that there are some other events that we can use, like key is down, or key pressed, or key released. These can tell us if a key is down or if the key is pressed. So if we wanted to know if any key is pressed, we could just use key is pressed. If we want to know if a specific key is pressed, we can use key is down. So let's look at key is pressed first. So if I say if key is pressed, and so this is a built-in value like mouse X and mouse Y, but it's going to act like our draw pink background. It's only ever going to be true or false. So let's say if key is pressed, let's do a fill. Let's do a yellow fill. And let's write some text. We'll say hi. And we'll put that in the middle of our drawing. So now if I press a key on my keyboard, we see hi. With key is pressed, it doesn't matter what key it is. It's just any key. And we'll see hi. So if we just want to know if a key is pressed, we just can throw that in there, and that'll be either true or false, depending on whether or not I'm holding a key down. If we want a specific key, I can say if key is down. The only thing with this is that we have to know our key values. So there's some built-in values like left arrow or up arrow. But if we don't know those values, then we can use the numbers for our keys. If you go to this website, it'll show you the values for each of your keys. So your keys have values that the computer uses to represent them. So if I hit A, it's 65, B is 66, C is 67. That keeps going all the way through. Z is 90. The numbers have their own numbers. So 0 is 48, 1 is 49, 2 is 50. Enter is 13, space is 32, tab is 9. So each key on your keyboard maps to a specific number that the computer uses to remember it. Okay, so let's say if key is down, and let's use 13 for the enter key. And if I'm using this, usually I'll put in the number here so I can remember it, because otherwise, I might not know what 13 is, or let's say 13 is enter key. I might not know what 13 is unless I've memorized the key map. So if I hit the enter key, let's also fill yellow, but I'll put some different text. I'll say, goodbye. Okay, so now if I hit enter, I get hi and goodbye. So let's maybe move it down a little bit. So if I hit enter, I get both, because key is pressed is true and key is down is also true. But if I hit another key, like A or B or space, I just get the first one, because this is just if any key is pressed, versus this is asking if a specific key is down. So that's another example. And so those are a few different examples of things. The key when we're actually starting to design a program is to kind of match some outcome that we want to some type of user input or something that happens over the course of a program. So I'll do another quick example, and then we'll have some workshop time. You guys can play around with different things. So one thing that we might want to do, and this is something that came up a little bit last week, and we came up with a different solution for this last week, but we can have a new solution for this now. You may have an animation that you want to restart at a certain point. So let's imagine that we have an animation of a circle growing. So I'm going to make a new variable up in the top of my program. I'm going to say let circle size, and I'll start it at 0. And so down here, I'll say we're going to reset an animation. So we'll draw a circle, and I'll put it in the middle of the canvas, and I'll use circle size as the size. And then I'll increase the circle size by 2 each frame. So I'll say circle size equals circle size plus 2. So I'm going to get this animation of the circle growing. So let's imagine that we wanted to reset this animation after a certain amount. I could say if, so I'm using a condition. So I could say if circle size, Okay, it looks like the projector is off. Let me see. It looks like it's an issue with the projector itself, because I don't see the blue light on there. Okay, I'm gonna stop the recording for a second.